Hi everybody, it's Mrs. Tucker. Let's do a review of factoring. We're going to start a module. Module 3 is on quadratic equations, solving them and graphing them and doing some word problems. Well, one of the skills that we have to solve a quadratic equation is we have to know how to factor. If you were in CPM4, we had a whole module on factoring. So let's do a quick review here on factoring. We are going to factor out a greatest common factor. We're going to factor by grouping. We're going to factor trinomials where your leading coefficient is 1. We're going to factor trinomials where your leading coefficient is a number other than 1. And we're going to factor a difference of 2 squares. So here is all of the steps. And I'm going to go through all of these steps. So if you want to pause the video and take a look at this, you're welcome to. I'm going to move on. Okay, on your vocabulary sheet number 2, factoring is the process of writing an expression as a product. Number 3, the greatest common factor of a list of terms is the product of all the common factors. I think at the end of this video, there's also some more vocabulary. Okay, I have an example here, 12x to the third and 18x squared. If you write the 12 and the 18 as prime factors, and then write your variable terms in expanded form, you can see what's common between the two. Here, 2 is common between those two groups. 3 is a common factor. X is a common factor. And this X is a common factor. You multiply those common factors together and you get 6x squared, and that's your greatest common factor between those two terms. Now I want you to take a look at something here. That x squared, take a look at these here. For your variables, your greatest common factor will always be the variable term to the smallest exponent. Always. Okay, one more thing that we need to remember is the standard form of all quadratic expressions. Standard form is ax squared plus bx plus c. All right. Okay, our first step in factoring, is there a GCF? I'm going to ask you this every time. Is there a GCF? Well, before I talk about factoring out a GCF, let's take this expression and multiply it. Here I have a monomial, it's one term, being multiplied by a binomial, 2 terms. And we're going to use distributive property to do that. I'm going to take 2x times x, and that gives me 2x squared. Bring down your addition sign. I'm going to take 2x times 3. That's 2 times x times 3. We'll multiply the 2 times the 3, and you get 6x. Okay? I wanted to show you the process of multiplying before I reverse that process. Now I'm going to take this product. This is a product. I'm going to start with the product, and we're going to factor out the GCF. So between the 2 and the 6, what's your greatest common factor? Yeah, it's 2. Between the x squared and the x, what is common between the two of those? Just a single x. Okay, so I pulled out my GCF. That's your GCF. Now to find out what's left, what goes inside the parentheses, this is what I do. 2x multiplied by what gives me 2x squared? Now that's got to be an x. Bring down the plus. 2x multiplied by what gives me 6x? Yeah, that has to be a 3. And you can see that's the answer that we should have gotten. That's the answer when we factor out the GCF. So if you need to add this to your notes, pause the video and jot that down. Okay, here's an example. I want you to factor this completely, and first thing I'm going to look for, is there a GCF? And I don't see a GCF. Okay, this is an example when you have 4 terms, your method for factoring is to factor by grouping. And this curriculum's pretty nice because they show you the way they want you to group it. If you've got 4 terms, we're going to factor by grouping. So I'm going to put a set of parentheses around the first 2 terms and a set of parentheses around the last 2 terms. Now, I'm going to factor out a GCF from both groups. Between the 16 and the 28, what's your GCF? Yes, that's going to be a 4. Between x to the 3rd and x squared, what do they have in common? That's going to be an x squared. Okay, so 4x squared multiplied by what gives you 16x to the 3rd? It's got to be 4x. Bring down the minus sign. 4x squared multiplied by what gives you 28x squared? Yeah, that's going to be a 7. Okay, over here in this grouping, bring down that plus sign. Between the 12x and the 21, what's common? Yeah, that's just going to be a 3. 3 times what gives you 12x? That's going to be 4x. Bring down the subtraction sign. 3x multiplied by what gives you 21? That's going to be a 7. Okay, the goal when you factor by grouping is to wind up with a common binomial factor inside the parentheses. And we do. 4x minus 7 is common in both of these terms. This is a term and this is a term because they are separated by addition. So what I'm going to do is I'm going to factor out that common binomial factor. I'm going to factor it out of each one of those terms. I'm going to factor it out just like we do with a GCF. This is a GCF. And what's left inside the parentheses, this quantity times what gives you this? Yeah, it's got to be that 4x squared. Bring in that plus sign. This quantity times what right here gives you this term here. Yeah, it's got to be the 3. And that's your answer. Okay? I always want you to check your answers before you go on. And I'm going to use FOIL. Since this is a binomial times a binomial, that little memory aid called FOIL will work. When I multiply these 2 terms together, my front 2 terms, I get 16x to the 3rd. When I multiply my outside 2 terms, you know, FOIL, front, outsides, insides, lasts. When I multiply my outside 2 terms, I get 12x, which is this term. When I multiply my inside 2 terms, I get negative 28x squared. When I multiply my last 2 terms, I get negative 21. Okay? That's what I want you guys to do every time when you factor to make sure you did it right. Because if you don't factor it properly, then what we're going to teach you about solving quadratics, I mean, if the factoring step isn't correct, your answer isn't going to be correct. All right? So if you need to jot this down, pause the video. All right. I want to show you how to factor trinomials, and I want to show you 2 different ways. I'm going to show you the book way, which is factoring by grouping, and a lot of professors will stick with the book way and factor by grouping, but I'm going to show you a second way with this problem because students seem to remember it better. It's exactly the same, it's just got a different setup. So before we factor, I want to show you how to multiply these 2 binomials together. And there's a couple different ways of doing that also. Okay, what I'm going to do is I'm going to take each one of the terms in here, in this set of parentheses, and multiply it by each one of the terms inside of this set of parentheses. So what I'm going to start off doing is taking the first term and multiplying it by that group. Okay, that's how I get this term here. And then I'm going to take the second term, I brought down that plus, take the second term and multiply by the whole group, which is this right here. Okay, now I'm going to use distributive property again. This times this gives you x squared. This times this is a plus 3x. This is a positive 2. That gives you plus 2x. And the positive 2 times positive 3 is positive 6. We have like terms here, so our answer is x squared plus 5x plus 6. Okay? FOIL, which is a memory aid for multiplying two binomials together, also works. Okay? And a lot of teachers are trying to get away from the FOIL because it's only a memory aid for binomial times binomial. If you had a trinomial here, you'd still have to do this distributive process. Actually, I use a box to do that, but FOIL is front two terms multiplied together, outside two terms, inside two terms, last two terms. Okay? But that only works when you take a binomial times a binomial. Okay, so that was a good review of multiplying two binomials together to get this as an answer. Now I'm going to take my product, this is the product, and I'm going to show you two different ways to get back to the two original factors. So you can pause the video here if you need to and jot down some notes. Let's take this product and let's factor it. And I'm going to factor by grouping. And I'm going to use what's called the AC method because I need to show you how do I go from this and break it down into these two terms right here. That's the trick. Once we've got these four terms here, then we're going to factor by grouping. So here's what I do. I set up this little T-chart. And you have to remember the basic form is ax squared plus bx plus c for all quadratics. This number here is your product of a times c. Well, in our trinomial, my leading coefficient is a 1. And 1 times my c over here of 6 gives me 6. My b term goes here. B is 5. That goes here. I'm looking for two factors of 6, two numbers that multiply to 6, but that add up to 5. 1 times 6 is 6, but when you add them together, you get 7. And that's not what I'm looking for. I'm looking for 5. 2 times 3 is 6. When I add them together, I get 5. That's what I'm looking for. Those are the two numbers I'm going to use. Do you see those two numbers over here? Yeah. Okay, so I'm going to take this x squared plus 5x plus 6, x squared plus 5x plus 6, and I'm going to replace 5x with these two numbers here. X squared plus 2x plus 3x plus 6. The x squared stays, the 6 stays, but I'm going to replace the 5x. This gets replaced with these two numbers here. Now I can factor by grouping. I'm going to group these two together. I'm going to group these two together. My GCF in this group is x. X times what gives you x squared? That's x. Bring down the plus. X times what gives you 2x? Now that's got to be a 2. Over here, bring down the plus. What's the GCF in this group? Yeah, that's 3. 3 times what gives you 3x? That's got to be an x. Bring down the plus. 3 times what gives you 6? There's your 2. The whole goal in factoring by grouping is to create that common binomial factor. When I factor that binomial Well, my video, I got cut off. We're going to factor out this common binomial factor. When we take that out, what's left to go in the other set of parentheses is your x plus your 3. X plus 3. And if you look at that answer, of course I always double check my answer, that is where we started, right here. So I wanted to show you that this factoring by grouping works. Now if you want to write down these notes, you can pause the video and do that. I'm going to take this exact same problem, the x squared plus 5x plus 6, and show you another way of factoring. And I call this the box method. Now let's review. I want to show you how the box method works when you multiply polynomials together. This is just like a multiplication table. If I had a multiplication table and I had 4 and 5 here, and 4 and 5 here, 4 times 4 is 16, 4 times 5 is 20, 4 times 4 is 16, 4 times 5 is 20. Okay? That's what we're going to do. I maybe should have used some different numbers here, like 2 and 3. 2 times 4 is 8, 2 times 5 is 10, 3 times 4 is 12, 3 times 5 is 15. We're going to do that same thing, but now we're going to throw in some x's. It still works! I'm going to put x plus 2 here, and the x plus 3 here. You could do it either way. The x plus 3 could go here, the x plus 2 here. And now I'm going to multiply. X times x gives you x squared. X times positive 2 is positive 2x. X times positive 3 is positive 3x. And a positive 3 times a positive 2 is positive 6. When you do that, we're going to have to combine our like terms right there. The 2x plus the 3x gives you 5x. So our answer is x squared plus 5x plus 6. That's exactly what we got the last time we multiplied these together. Now let's take our product of x squared plus 5x plus 6 and let's factor it back into its two factors. And I'm still going to use the box, and I still have to use my little t-chart. I'm going to use this AC method to figure out how do I bust down 5x to get those two factors that I need so this whole thing works. Okay, so a times c, well my a here is 1. 1 times 6 is 6, so 6 goes right here. Your b term, your 5, goes here. I'm looking for two numbers that multiply together to give me 6, but they add up to 5. Well, those add up to 7. 2 times 3 is 6, 2 plus 3 is 5. There's the two terms I want to use. So with the AC method, you're going to put your x squared here, your 6 goes down here. Same thing we did when we factored by grouping. We kept the x squared, we kept the 6, but replaced the 5x with 2x and 3x. Now I'm going to factor out GCFs. The GCF in this row is x. The GCF in this row is 2, and because the adjacent box is positive, that term's positive. The GCF in this row is x. The GCF in this row is 3. Because the adjacent box is positive, that guy's positive. And now you have your two factors, the x plus 2, the x plus 3. And that is what we originally started with. Okay? I always want you to double check your answers. You know, with a binomial times a binomial, you can use FOIL. Double check and make sure you get back to your original. And you do. Okay? So from this point forward, I'm going to use both methods. And I just want you guys to pick whichever method works for you. I'm certain that if your professor is a factor by grouping kind of guy or gal, but you prefer the box method, they're going to be okay with that. So you just use whichever method works best for you. All right, I'm going to factor x squared plus 6x plus 8. First of all, is there a GCF? Here, no. You always have to factor out a GCF first. Okay, factoring by grouping or factoring using the box method, both of them, I'm going to use that ACT chart to figure out what I'm going to rename 6x. Okay, it's either going to be 1x and 6x or 2x and 3x. We got to come up with a plan here. So my A is 1, my C is 8, so 8 goes there. My 6, my B term goes here. I'm looking for factors of 8 that add up to 6. 8 times 1 is 8, but when you add those together, you get 9. So let's try 2 and 4. 2 times 4 is 8. When you add 2 and 4, you get 6. Those are the two numbers we're going to use. So with the factoring by grouping, I'm going to replace 6x and call it 2x plus 4x. Now I can group your front two terms together, group your last two terms together. The GCF in the front group is x. So I factored out an x. Let me back that out. I factored out an x. X times what gives you x squared? Yeah. Bring down the plus. X times what gives you 2x? Yeah, that's got to be a 2. Bring down that plus sign. GCF in this group, yep, that's 4. 4 times what gives you x? Yep, bring down the plus. 4 times what gives you the 8? Yep, that's got to be a 2. Here we have a common binomial factor, and that's your goal. You want a common binomial factor because when you factor that out of each one of these two terms, here's a term and here's a term. When you take out the x plus 2 and you factor it out, what's left? Yeah, x plus 4. All right, double check your answer. Front two terms is x squared. Outside two terms is 4x. Inside two terms is 2x. Last two terms is 8. When you add these two together, you get 6x, and you factored correctly. Okay? Using the box method, your x squared goes here. Your 8 goes here. Just like down here, x squared didn't change and your 8 didn't change. But I'm going to rename the 6x. I'm going to rename that 2x and 4x. Now, you got to go in this direction. You got to go left, because if you go the other direction, you'll get your signs wrong. Factoring out going left, what's your GCF here? Yes. Factoring out your GCF in this row, what's your GCF? It's 2. And because this adjacent box is a positive number, this is a positive number. Now you have to go up. If you go down, you might get your signs wrong. If you go up, your GCF here in this column is x. The GCF in this column is 4. Because this adjacent box is a positive, that's a positive. So now you should have your two factors, x plus 2 and x plus 4. And if you look over here, it's identical to this. It's pretty much the same method done in two different forms. It's the same method done in two different forms. Pick your form. Which form do you like? Pick a form and stick with it. Okay, let's do this one. And I'm going to speed things up a little bit. The only difference between this and what we had before is our B is negative. Is there a GCF? No. I'm going to use the AC method. I'm going to take 1 times 15. That's 15. This B term here, negative 8, goes there. I'm looking for two numbers that multiply to 15, but to add up to negative 8. Yeah, and that's not going to work, is it? If I do positive 3 times positive 5, that's positive 15. That adds up to positive 8. Let's make both of those factors negative. Negative 3 times negative 5 is positive 15. When you add -3 plus -5, you get the -8. There's the two terms I'm going to use. I keep the x squared, I keep the 15, but I rename -8x as -3x plus -5x, and that would probably be the better way to write it, because you don't want to separate, you don't want to put a set of parentheses in between that negative and that 5. If you do, you're not going to get a common binomial factor. So minus 3x, it might have been better to have said plus a -5x plus 15. Now when you wrap your parentheses around here, everything's going to work out. GCF, what goes here? X squared, what times x times what gives you -3x? GCF here, well, that's 5. Watch what happens here. 5 times what gives you -5x? That would be a -x. 5 times what gives you +15? That's a +3. We do not have common binomial factors here. These are opposite in sign of what we want right here. So to fix that, we're going to factor out a -5x, not a +5x. Let's make it negative. -5x. Now, -5 times what gives you -5x? Yep, that's just an x. -5 times what gives you +15? That's got to be a -3. There's our common binomial factor. Factor it out, x minus 3. Then x plus -5x is the same as x plus -5 is the same as x minus 5. Okay? I'm going to do my check. That's x squared. Outsides gives me -5x. Insides gives me -3x. Last two terms is +15. When I add these two terms together, I get the -8. Always check your factoring. Okay? Be careful here. You don't want to put that parenthesis in between that negative sign and the 5. If you do put the parenthesis there, then you have to change this sign right here. If it's negative, it becomes positive. If it's positive, it becomes negative, because what you just did is you factored out a -1. So be careful. You might want to call this subtraction adding a -5x. If you do that, everything's going to work out. All right? Let's use the box. If you use the box, then you don't have to worry about that. Okay? My x squared goes here. My 15 goes here. I'm going to put -3x. It doesn't matter where they go in these two boxes. -3x, -5x. If you're using box, you don't have to worry about this parenthesis business here. Yay, box. GCF in this row is x. GCF in this row is 3, but because the adjacent box is negative, this has got to be negative. GCF in this column is x. GCF in this column is 5, but because the box adjacent is negative, this has got to be negative. So our two terms are x minus 3, our two factors are x minus 3, x minus 5. Yay, box! If you do box, you don't have to worry about separating a negative sign from its term here with the grouping. So you guys can kind of tell I'm a box fan. Yeah. All right. Here's another example. GCF? No. AC method? Yes. 1 times -14 goes here. The 5 goes here. I'm looking for factors of -14 that add up to +5. I got -5. Switch your signs around. -2 times +7 is -14. When you add -2 plus 7, you get 5. I got cut off again. Okay, so our two factors are our x minus 2 and our x plus 7, just like what we got over here. Okay? Let's do another problem. Okay, this time our leading coefficient is a number other than 1. We definitely need our AC method here. GCF? No. All right, let's make our little ACT chart. I want to take my A times my C. You know, remember its standard form is AX squared plus BX plus C. So I'm going to take the 2 times the 3, and that's 6. 6 goes here. My B term, my positive 7 goes here. I'm looking for factors of 6. Two numbers that multiply to 6, but add up to 7. These add up to 5. So it's going to be 1 times 6, which is 6. 1 plus 6 is 7. There's the two numbers I'm going to use. I'm going to replace my 7x with 1x plus 6x. I'm going to factor by grouping over here. I'm going to take a GCF out of both groups. My goal is to create a common binomial factor. And I did it. My common binomial factor is 2x plus 1. Factor that out of each term, and what goes in the other set of parentheses is the x plus 3. Double check your answer with, since it's two binomials, double check with FOIL real quick. I checked, it's good. If you're using the box method, your 2x squared goes here. Your plus 3 goes here. You're going to put 1x and 6x in these two boxes. It doesn't matter where you put it. 1x, 6x. GCF in the top row is 2x. GCF in the bottom row is just a positive 1. GCF in this column is x. GCF in this column is 3. It's a plus 3 because the adjacent box is a positive. The adjacent box is a positive here. So your two terms are x plus 1 and x plus 3. Your two factors, I should say. The factor of 2x plus 1 and the factor of x plus 3, which is just what we got over here. Okay? This one looks different. Remember our basic form for all quadratics is ax squared plus bx plus c, our standard form. We're missing this linear term here. Something's different about this one. I have only two terms. I'm taking the difference of those two terms. Those two terms are perfect squares. X squared is x being squared, and 25 is 5 being squared. This is what we call a difference of two squares, and it has a factoring pattern. You're going to use the x and the 5, and you're going to create your conjugates. X plus 5, x minus 5. Conjugates have the same terms, but the sign in between is opposites. Now double check with FOIL. This gives you x squared. Outsides gives you negative 5x. Insides gives you plus 5x. Last two terms is negative 25. In CPM4, Module 2, we learned that conjugates do create two terms that will cancel each other out. They create a zero pair. And you're left with the x squared minus 25. Okay? That's difference of two squares. And you've got to recognize this. Let's try another one. I'm missing that linear term here. It's not a trinomial, it's a binomial. I have two terms and I'm subtracting. I should be thinking this is a difference of two squares. Are the two terms perfect squares? Yes, the 4x squared is 2x that's being squared, and 9 is 3 that's being squared. There's your two numbers, your two terms that are going to go inside the parentheses. So it's 2x plus 3 and 2x minus 3. If you check with FOIL, front two terms give you the 4x squared, and the last two terms give you the negative 3. Insides, outsides, your OI, outsides, insides, will cancel each other out. This is negative 6x, this is positive 6x. You create a zero pair and they drop out. Okay? Let's factor this one. Is there a GCF? Yes! Your GCF here is what? Yeah, it's 2. So our first step is you've got to take your GCF out. Factor out your GCF. What's left inside the parentheses now is what you're going to factor. You're going to continue factoring. My AC method, I'm going to take the 7 times the negative 5. That's negative 35. My 2 goes here. Factors of negative 35 that add up to 2. There we go. That's what I'm going to use. I'm going to drag my GCF with me because a lot of people will factor out the GCF and then forget to put it in the answer. Okay, so I'm replacing 2x with the negative 5x plus 7x. I'm going to factor by grouping. Group the first two terms, group the second two terms. Take out your GCFs in both of those groups. GCF here is x. The only GCF here is 1, but go ahead and factor it out. Did we create a common binomial factor? Yes, we did. So factor it out, and what goes in the other set of parentheses is your x plus 1. Double check your answer with FOIL, redistribute the 2, you'll get back to your original. Okay? If we use box method, still you're going to factor out your GCF, and what goes inside the box is your 7x squared here, your minus 5 here. These two boxes are going to be negative 5x and the positive 7x. GCF in the top row, GCF in the bottom row. Because the adjacent box is negative, this term's negative. GCF in this column, GCF in this column. It's just 1. And because this adjacent box is positive, that's going to be positive. So the trinomial factors into x minus 5, that quantity, times the quantity of x plus 2. Don't forget your GCF. All right? Same as what we got before. Let's do another one. Is there a GCF? Yes. And it's not just 3. Look at those variables. They all have x's in them. Take the x to the smallest power. It's going to be 3x. Factor out your 3x. The trinomial inside is what we're going to factor. My a times c, 3 times negative 5 is negative 15. My b is negative 2. I'm looking for factors of negative 15 that add up to negative 2. There we go. Replace negative 2x with 3x minus 5x, or negative 5x plus 3x. We're going to group these two terms here and group these two terms here. The GCF in this group is x. The GCF in this group is 1. Factor those out. I have my common binomial factor. Don't forget your GCF. So it's the GCF times the quantity of 3x minus 5 times the quantity of x plus 1. Double check with FOIL. Double check with distributed property. You should be able to get back to your original up here. Okay? If we're using box, we still have to take out the GCF. We still have to use AC method. 3x squared goes here. This negative 5 goes here. The 3x and the negative 5x. Okay? GCF in this row. GCF in this row. Because the adjacent box is negative, this term has to be negative. GCF in this column is x. GCF in this row, it's just 1. And since the adjacent box is positive, this is going to be a positive 1. Don't forget your GCF here, your original GCF, the 3x times the x minus 5 times your x plus 1. All right? Here's some extra examples. I am going to mute the video, but just click through it in case you need more examples. How's that sound? All right.